the quadratic formula is probably one of the most important formulas that we use in upper levels of mathematics. And so as we go through a lot of these formulas when we've seen them for the first time, like equation for a circle or distance formula or something like that, we've talked about where it came from and how we get it. So we want to do that same thing here with the quadratic formula. And this one is important enough for me that you understand the reasoning behind it, where we get it from, the proof of it, if you want to call it that, that I'm literally making this the bonus for your test this week. So this will be worth 5 points on your test this week. Basically, the directions will say exactly what this does. Create the quadratic formula by completing the square on ax squared plus bx plus c. And at the top of the page, it'll just say ax squared plus bx plus c equals 0. You do not need to write any of this over here. All you need to do is just regenerate this for me. Doesn't have to be exactly like mine. Don't have to show as much work as I do. And you can get partial credit. So even if you move the constant to the other side and maybe do the first, 1 or 2 steps up here and then you give me the formula down at the bottom, you might be able to pick up a point or 2. So because this is probably going to take us about 10 minutes in class to do, and we don't want to take time away from your test on Friday, then we'll do this on Tuesday when we come in, because Monday's a holiday. First thing when we come in on Tuesday, we'll do this bonus. Okay? So let me go through this with you so that you can see how this works, because it's not memorization as much as it is just understanding the steps in the process. So step number 1, when we're completing the square, we move the constant to the right-hand side of the equation. So we could take this plus c and subtract it over to the other side. Step number 2, we want to divide both sides by the leading coefficient. So our leading coefficient is a, so we want to go through and divide everything by a. So ax squared divided by a is x squared. B divided by a is b over a. And negative c divided by a, negative c over a. All right. Then we said to create that perfect square, what we would want to do is take the coefficient of the middle term, which is b over a, cut that in half. So if you had 1/2 of b over a, that would just be b over 2a, right? And then square that, so there's our square, and add that to both sides. So the pattern for completing the square was to take the coefficient of the middle term, b over a, cut that in half, so half of b over a, 1/2 times b over a would be p over 2a, and then square that, so there's our square, and add that to both sides. So you can see we've done that right here. We've added that b over 2a squared to both sides. And over here on the right-hand side, we just simplified it a little bit because b squared is b squared, 2 squared is 4, and a squared is a squared. All right? Next thing says factor your perfect trinomial square. So if I have x squared, that would factor down to x times x. And if I have b over 2a squared, that's going to factor down to b over 2a times b over 2a. So you could write that as x plus b over 2a squared. So we have factored it as a perfect trinomial. Then we want to take the square root of both sides to solve that. Okay, so we'll go through and we'll insert a square root on each side. So the square root of the square will drop out over here and just give me x plus b over 2a. And then we're going to solve for x and simplify. So while we've been kind of focusing over here, there's been all kinds of stuff going on over here too. So let's kind of focus on that right-hand side for a second. We understood that we added the b over 2a squared right there. But then we started to do some simplifying on this side. I have fractions that I could combine if I got a common denominator. So what would the common denominator for a and 4a squared be? Common denominator for a and 4a squared. 4a squared, yes. So we're going to rewrite each of these with a denominator of 4a squared. So this one I don't have to change, but this one I do. So what did I multiply by to get from a to 4a squared? 4a. So I'm going to do the same thing in the numerator. I'm going to multiply that c by 4a, and that's how we get 4ac. The purpose of creating a common denominator is so I can combine my numerators over that, right? So let's take those two separate numerators, b squared and negative 4ac, and let's combine them over that common denominator. Although I can't simplify that numerator just yet, My denominator I could, because the square root of 4 is 2 and the square root of a squared is a. Right? So now we're ready to solve for x. So if I'm going to get x by itself, what do I need to do with this b over 2a? Subtract it over to the other side, right? So let's subtract b over 2a over to the other side. And when we do that, now we could get a common denominator, or I could combine those two numerators over that common denominator of 2a, and it magically just so happens to be my quadratic formula. Okay, so that's where it comes from. That's where we get it. 5-point bonus on this test. So I don't always tell you what your bonus is going to be, and typically it's just a 3-point bonus, not a 5-point bonus, but this one is especially important. So giving you a heads up and giving you a few extra points of motivation to work with it. Okay? All right, so we want to finish off section P4 today. Remember, we've been talking about solving every type of equation we've ever seen in all of our life, all in one section kind of thing. So going to continue with that same thought process today with example 9. All right, example number 9, they give me 4 terms. How do you factor when you have 4 terms? Any ideas? If I had an x in every term, absolutely. I would take out the greatest common factor. I would take out an x. My problem here, though, is I don't have an x in that 4th term. Any other ideas?
Take out 2.
All right, I could go through and take out a greatest common factor of 2. Any other ideas? Factor by grouping, right. So I'm going to go through. I could take out that common factor of 2 first, or I can go through and group first, either one. So I'm going to factor by grouping. And remember, when you group, be sure that you put the sign of that 3rd term inside the parentheses. If you put that parenthesis in between the negative and the 6, you've just factored a negative out, and that's going to change every single sign in that whole set of parentheses. So we want to be careful with that. All right, so we're going to take out the greatest common factor out of our first 2 terms and take out the greatest common factor out of our last 2 terms. The only way I can factor by grouping is if what's left inside the parentheses is identical. I have to have an x minus 3 here and here in order to be able to continue. Now, let me come over and just kind of give you a parallel problem for just a second. Let's say that you had 2x squared y minus 6y. If you had those 2 terms, you were taking out the greatest common factor. We could see there's a y here and there's a y here that we could take out. So when I take out that y, I'm left with 2x squared minus 6, right? Does everybody see that? Does that make sense? Okay. When I take out that y, even though I'm taking out a y here and here, I don't write it as y squared, right? But for some reason, when we do that exact same thing over here, here's 1 term, here's 2 terms, they each have an x minus 3 in them. All I've done is put x minus 3 in the place of y. I'm going to take out a common factor of x minus 3 then. And when I do, it's not x minus 3 squared. I just took out 1x minus 3 out of each of those terms. If you distributed it back through, you'd go right back to that step up above. So it's just x minus 3, not x minus 3 squared. Additionally, you could put your finger over this x minus 3 and put your finger over this x minus 3, because that's what you've taken out, and whatever you have left is your other term, is your other factor. So my other factor then would be that 2x squared minus 6. So once I have it factored, I know what to do from there. I can just set each of my factors equal to 0 and finish solving. So what do we need to do next over here with the 2x squared equals 6? (2x squared equals 6). How do I get x by itself? All right, let's divide both sides by 2, and then what? How do we get rid of that square? Square root of both sides, right. And let's insert a plus or minus when we put in that square root. So that's our factoring by grouping. All right, examples 10, 11, and 12 ask us to deal with solving equations that have radicals in them. What undoes a square root? A square. So if I'm going to go through it, I'm going to insert a square. Remember, the rule is what you do to one side, you do to the other side. I don't get to square just this one piece, right? I'd have to square this whole side. Well, as it is right now, if I square that whole side, I'm foiling with a radical. Just not a whole lot of fun. So for that reason, the first thing we always want to do is try and get the radical on one side by itself so that then when I square it, it's easier to work with. So if I'm going to get this radical alone on one side by itself, I'm going to start by adding that x to the other side. Then I can square both sides like we were talking about to undo that radical, but I won't have to FOIL with that radical. I'll still have to FOIL on the other side, but that's a little bit easier than FOILing with a radical. So the square root and the square are going to drop each other out on the left-hand side. On the right-hand side, when you see 2 plus x, the most common mistake I get there is 2 plus x squared is 4 plus x squared. 2 plus x squared literally means 2 plus x times 2 plus x. I do need to FOIL that out. I can't just like square the first term and square the last term. All right, and so then I've got a quadratic that I can move it all over to one side set equal to 0. So I'm going to subtract the 2x, and I'm going to subtract the 7. And then you're back to, you can do factoring, completing the square, quadratic formula, whatever you'd like to do. If it factor we saw yesterday, that's probably the fastest, easiest way to do this. So x squared would, of course, factor to x times x, but what multiplies to be -3 and adds to be +2? Multiplies to be -3, adds to be +2.
+3, -1.
Yeah, +3 and -1. Set each of those equal to 0, and I've got my solutions. Now, we mentioned that you would need to check for extraneous roots on some of these problems that you were solving. We had to do that when we multiplied both sides by a variable that wasn't there in the original problem, right? So I look at this one, did I multiply both sides by a variable? I don't see anywhere I said times x on each side, right? So I must not have. Well, actually I did. And this is really, really easy to miss. Okay, what did we do to solve this? We inserted a square on both sides, right? So originally this was just 2 plus x, but when I put that square in there, that said multiply by 2 plus x again, right? So that's a really easy one to overlook. I did multiply by a variable that's not there. I do need to check these. And so sure enough, when I plug them in, one of them works and one of them doesn't. I do have an extraneous root. Now, you don't have to write your checks out on your paper, not even on your test. You're welcome to just check them in your head. So if I take that -3 and I plug it back in up here, that's going to be 2 times -3, so -6 plus 7 is 1, square root of 1 is 1, minus a -3 would be 1 plus 3, so that'd be 4. And that's supposed to be equal to 2, and it's not. So that's how we knew that one was extraneous. However, when we plugged in the 1, we did get 2 equals 2. We got a true statement, so that is our only true solution. All right, let me put a disclaimer on example 11 before we start. It's obnoxious. For that reason, this is not on your test. It is not on your quiz. The only place that you're going to do something like this is it is going to be the challenge on your review homework assignment, which means it's going to be worth bonus points because that's a graded assignment, right? So you could decide whether you wanted to do it or not after you saw it. Entirely up to you, but if you want to play around with it and try and pick up a few extra points bonus on your quiz, then you're welcome to. So let's look at how this would work. We said that when you're working with a radical that you want to isolate the radical. You want to get it alone on one side. I can't really do that in this problem. The best I can do is to get one radical on one side and one radical on the other side, but that's as good as it's going to get. So I'm going to square both sides to get rid of that square root. But unfortunately, I'm going to end up over here foiling with a radical. So when we have the square root of 2x plus 6 squared, no problem. Square root and square drop out. But over here, when I have 1 plus the square root of x plus 4 squared, that literally means 1 plus the square root of x plus 4 times 1 plus the square root of x plus 4. I literally have to FOIL that out. So that would be 1 plus the square root of x plus 4 times 1 plus the square root of x plus 4. So if you FOIL that, 1 times 1 is going to give you 1. 1 times the positive square root of x plus 4. 1 times the positive square root of x plus 4. And then x plus 4 times x plus 4 underneath those radicals would give me just a plain x plus 4. Square root of x plus 4 and square root of x plus 4 is just 2. square roots of x plus 4. And then, of course, we could continue simplifying, but I just wanted you to see how I got to that point right there. Okay? So all we did was just FOIL out that 1 plus the square root of x plus 4, and that's how we've gotten to that line right there. Okay? So if we continue combining, if you'll notice, this is like 2 problems in one. This, where we are right now, would be like the beginning stages of something we just did in example number 10, where we said anytime you've got an equation that has a radical in it, get the radical alone on one side, get everything else on the other side. So that's what I'm going to do. I'm still going to try and isolate this radical. So I'm going to try and move this 1, 4, and x over to the other side. Okay? So if I combine the 1 and the 4, that would be 5. Move that over to the other side. So 6 minus 5 is going to give me 1. Same idea, I had this x, when I moved it over to the left-hand side, 2x minus x gave me 1x. So then I would be left with just the radical, just the 2 square roots of x plus 4 on the right-hand side. The reason that we isolate the radical is so that we can then square both sides, right? Now, you could have divided both sides by 2 as well. I didn't because I'm just not a great big fractions fan. So I'd rather leave it there and square it than move it to the other side and have to fight with a fraction. But you could do whatever you want to do. So I'm going to square both sides. Don't forget again that when you square x plus 1, that's x plus 1 times x plus 1. So you got to FOIL that out. So it's not just x squared plus 1. It's x squared plus 2x plus 1 when we FOIL it. And then over here, 2 squared was 4, and the radical and the square canceled each other out. Now that 2 was being multiplied times the radical, so I still am going to have its square 4 being multiplied by that whole quantity in parentheses, not just times the first value. So we can distribute that 4 to everything in parentheses, and now we're back to something normal. We've got a quadratic that we can solve. So let's move it all over to one-hand side, set equal to 0. And then you could factor, completing the square, quadratic formula, whatever you wanted to do to finish solving that. So once we get to about right here, we're okay. It goes back to the same thing we were doing in example 10. It's just that it's like doing 2 problems in one is what makes that one more challenging. And just like we saw in example 10, we do have to check our answers for extraneous roots. And sure enough, one of them worked and one of them didn't. So I got 1 real solution and 1 extraneous root. All right, example 12 is another radical equation. They've just written it a little bit differently. Remember that when you have an equation that has a fraction in it, the numerator of your fraction remains your exponent, but the denominator of your fraction becomes the index of your radical. So because that was to the 2/3, I'm going to keep that exponent of 2, but I'm going to write this as a cube root. So that's just another way that they might give you a radical equation to have to solve. Okay, so let's isolate the radical alone on one side. That's already done. Then step number 2, we're going to get rid of the radical. So what would get rid of a cube root? Cube it, right. So let's cube both sides. So the cube root and the cube would drop out. What's 4 cubed? 4 cubed, 64, yeah. Still trying to get x by itself, so now I have to get rid of that square. What undoes a square? Square root. So let's put in a square root on each side. Don't forget your plus or minus. And the square root and the square cancel each other out over here on the left like we wanted them to. And over here on the right, we're left with plus or minus 8. So how do we get x by itself?
Subtract 1.
Yep, subtract 1 from both sides. And of course, we wouldn't leave it that way. We would say -1 plus 8 is 7 and -1 minus 8 is -9. And as we saw with the other radical equations, I do have to check for extraneous roots, and when I check this time, they both work. On example 12, both of those solutions checked. just because you have the chance of an extraneous root doesn't necessitate that you have an extraneous root. It is possible for all of the answers that you get to check and work. That's perfectly fine. We just do have to check. Okay, example 14, we have an absolute value equation. Absolute value equation. So let's think of just a basic absolute value for just a second. Let's say that you had the absolute value of x is equal to 3. What could x be? If the absolute value of x is 3, what number could you take the absolute value of and get 3? 3 or negative 3, yeah. So we just discovered the rule for an absolute value equation. Anytime you want to solve an absolute value equality, you're going to take what's inside the absolute value and set it equal to a positive and a negative of what's on the other side. So that's what we're going to do down here. We're going to take what's in the absolute value, x squared minus 3x, and we're going to set it equal to a positive of what's on this other side and a negative of what's on that other side. Now, when you have a positive times something, does it change anything? No. So if I go through and I distribute this positive here, I'm still going to have negative 4x plus 6. But when I come over here and distribute this negative, going to change every one of those signs, right? Okay, so let's work with the first one. If I go through, remember we said this wouldn't be changed at all, so let's just move it all over to one side since it's a quadratic, set equal to 0. And then you're back to solve that any way that you want to. You could solve it by factoring, completing the square, quadratic formula. This one factors pretty easily, so that was the route that I went. But for the second piece over here, we're going to need to deal with this negative. So we need to go through and distribute that negative, and it will change every one of those signs. Negative times a negative is a positive. Negative times a positive is a negative. And then move it all over to one side and continue factoring. Now, this one is really hard to see why we might have extraneous roots. But in essence, we started off with one equation and we wrote it as two separate equations. So we did introduce some x's that weren't there originally. I know that's the rule and we have to do that. We didn't have a choice because that's how you solve it. But we do run the risk of picking up extraneous roots here. And sure enough, when we go through and we plug these 4 solutions back in, 2 of them don't work. 2 of them are extraneous. So I do need to check for extraneous roots here as well. Okay, so here is our homework for tonight. Just a couple of these tonight. 5 will be plenty. On pages 50 to 53. And remember that we have our quiz tomorrow over the second half of P3 and all of P4. We've spent like 3 days on P4. So the second half of P3 and all of section P4 is what we need to know for our quiz tomorrow. You do not need any calculator of any kind for your quiz tomorrow, so you won't be using any. I don't put big obnoxious numbers on the quizzes, so you don't need a calculator for your quiz tomorrow at all.